Welcome everyone, come back to this class again. The chapter introduced in this video is data query. In today's lecture, I will go through SQL, which is the useful query language and successfully used in most of the relational database systems. In syllabus, the hour spending on this chapter is 3 hours. Because of time limitations, we will spend 1 hour to introduce these chapters, and more details will be taught in the physical classroom. Let's take a look at the outline. First, I will make an overview of SQL query language, and then SQL data definitions will be introduced. We also explore basic query structure of SQL queries, and then SQL clause, join clause, and aggregate functions will introduce in this chapter. If we look forward the history of SQL, in the beginning, IBM SQL language developed as part of System R project at the IBM St. John's Research Laboratory, and then is renamed Structured Query Language (SQL). And ANSI and ISO also create some standards for SQL, such as SQL 86, 89, 92, 1999, and 2003. Commercial systems offer most, if not all, SQL 92 features, plus various feature sets from data standard and special proprietary features. So not all examples here may work on any particular system. In SQL, it contains 3 different languages. One is DML, which is data manipulation language. It provides the abilities to query information from the database and to insert tuples into, delete tuples from, or modify tuples in the database. And the second language is the Data Definition Language (DDL), which includes commands for specifying integrity constraints or any objects. In addition, DDL also can help view definitions and the transaction controls. And here's a spatial SQL, which is called embedded SQL or dynamic SQL, can define how SQL statements can be embedded within general-purpose programming language. And finally is DCL's data control language, which mainly deal with authorizations, including commands for specifying access rights to relations and view. And now, we will talk about data definition language, or we can call it DDL. This language allows the specifications of information about relations, including the schemas of each relation, the schema of each relation, the type of values associated with each attribute, and the integrity constraints, the sets of index to be maintained for each relation, and securities and authorizations information for each relations, the physical storage structure of each relations on disk. In general, DDLs mainly deal with the definitions of the database system. So here is the create table constructs. A SQL relation is defined using the create table commands like this. Create tables keywords and followed by the relation name. Here we have to indicate the attribute names and its domains, followed by its integrity constraints. Let's take a look at this example. It's examples of creating the instructor table. So here's we have to give this class create table instructor followed by the attribute names ID and its domain character 5 and names varchar 20s, department names varchar 20 and the salaries numerics data type. In addition to the basic structures of a table, there's types of integrity constraint, including primary key, foreign key, non-null constraint. Through these integrity constraints, SQL can prevent any updates to this database that violates any integrity constraints. If we also consider the integrity constraints in these tables, followed by the basic structures of a table, we have to write down the primary key, which indicates ID is the primary key, and the foreign keys, which indicates department name, is a foreign key, which references the primary key of department. So we can look at some more examples. And here is a few more relation definitions. If we want to create student table, the class is create table students and followed by the attribute name and their data domains. And then we have to define the primary key and the foreign key. And here's foreign key have to further indicate the reference. And here's text tables can be created with the similar clause. For examples, create table text followed by its attributes name and their data domains. Finally, we have to define the integrity constraints such as primary key or foreign key if we have these integrity constraints. After introducing data definition language, now let's learn about the data manipulation language. And here is the typical SQL language. In these forms, it contains the keywords of select, from, and where, followed by the keyword select. We can indicate the attribute names we want to retrieve, and followed by the keywords of from. We have to indicate the relation name. And if this query contains conditions, we can indicate these conditions. And we have to notice that the result of any SQL query is also a relation. And now let's examine the query forms in detail. First is the select clause. The select clause lists the attributes desired in the results of a query. It usually corresponds to the projections operations of a relational algebra. For examples, if we want to find the names of all instructors, we can have this statement select name from instructor, and in any SQL statement, the attribute names are case insensitive. That is, you may use upper or lower case letters. And the SQL allows duplicates in relations as well as in query results. To enforce the eliminations of duplicates, insert the keyword distinct after select. For example, you can find the department name of all instructor and then remove duplicates. Here we can have this statement: select distinct department names from instructor. Of course, the department names is corresponding to the attributes names in instructors table. The attribute names have be the same as the attributes in a table. The keywords or specifies that duplicates should not be removed. So if we indicate ORs, it means it has to the duplicate records have to be listed in the result. And the select clause can contain arithmetic expressions involving the operations plus, minus, product, and the division, and operations on constants or attributes of tuple. For examples, if we want to retrieve instructors' ID, names, and the monthly salary, we can use. So here's the attribute salaries can be divided by 12, and we can obtain the value 3 salary. And if we want to focus these values with a column names monthly salary, we can use as to indicate to give these attributes as an alias. As to the where clause, the where clause specifies conditions that the results must satisfy. It corresponds to the selection prediction of a relational algebra. To find all instructors in computer science department, we can have this where clause, followed by the keywords of wheres. The attributes department names is equals to computer science. And if we have more conditions, we can use the logical connective and, or, and not. And the operators of the logical connectives can be expressions involving the comparisons operators less than or equal, more than and equals, equal to, and not equal to. Comparison can be applied to results of arithmetic expression. For examples, we can find all instructors in computer science department with salaries more than 80,000. So here's the where clause can be indicated with department names is equal to computer science and the salaries is more than 80,000. So with this logical connective, we can connect more conditions, and in each conditions, we can use comparisons operators to fill out the data what we need. And the front clause lists the relations involved in the query. It corresponds to the Cartesian product operations of the relational algebra. In these query statements, followed by the keywords from, two relation names are indicated. It also means we want the results of Cartesian product. It will generate every possible instructor-teaches pair with all attributes from both relations. From common attributes such as ID and the attributes in the resulting table are renamed using a relation name such as instructor ID. Cartesian products not very useful directly, but useful combined with where clause condition. And now let's examine some example. Find the names of all instructors who have taught some course and the course ID. So here we can, these attributes we need come from which relations. And here we can find we need the instructors and the teachers relations. So we can indicate the names of these two relations followed by from. And the attribute names we need is instructor name and the course ID. So we can define these two attributes names followed by the keyword select. As to where's clause, we can, because these queries involves joins, so we have to join these two relations with ID. However, these two relations with the same attributes ID, so we have to indicate the relation name. For example, instructor.id and the teachers.id. These queries can help us to join the tables of instructor and the teachers with the same IDs, and finally displays the instructor names and the course ID he taught. And the second example is find the names of all instructors in the arts departments who have taught some course and the course ID. So here's this example is almost the same with the upper ones. However, we have to indicate more conditions, which is instructor's department is equal to art. And the renames operation. The SQL allows renaming relations and attributes using the as clause. And here's the clause is all name as new name. In other words, the new names is an alias for the old name. and the strings operation. SQL can include the string matching operators for comparisons on character strings. The operators like use patterns that are described using two special characters. One is percent, the other one is underscore. The percent characters matches any substring, and one's underscores characters match any one's character. For examples, find the names of all instructors whose names includes the substring stars. Here we can indicate the where clause with name like percent stars percent. Finally, the result will include any characters contains star string and match the strings 100%. Here, percent character is the part of real condition instead of a character used in strings operator, so that we can use backslash in a where clause to reveal its escape character. We also can order the displays of tuples. This in alphabetic order the names of all instructor. Select distinct name from instructor order by name. It means the names will be displayed according to alphabetic orders in an ascending order. We can specify DESCs for descending order or ASC for ascending order. For each attribute, ascending order is the default. For examples, order by names descending. In addition, we also can sort on multiple attributes. For example, there are two attribute names followed by the keyword order by. It means the results will display according to the first priority's department names and then the second priority's name in ascending order. As two null values, it's possible for tuples to have a null value denoted by null. For some of their attributes, null signifies an unknown value or that the value does not exist. The result of any arithmetic expressions involving nulls is null. For examples, 5 plus nulls also returns null, and the predictions is nulls can be used to check for null values. For examples, find all instructors whose salaries is null. Here we can indicate the conditions is salary is null. Here we have to notice that we cannot have the clause salaries is equal to null, because here null is the special data type, and the predict is not null succeeds if the values on which it is applied is not null. So SQL treats as unknowns the results of any comparison involving the null value other than predicts is null and is not null. For examples, 5 less than null, or null not equal to null, or null is equal to null. The predicts in a where clause can involve Boolean operations. Thus, the definitions of the Boolean operations need to be extended to deal with the values unknown. For example, if we use logical connective AND, it will compare true and unknowns, and then it will return unknowns. And if we use ORs, unknown or true, it will return true. And the results of where clause predicts is treated as false if it evaluates to unknown. After learning how to retrieve data with data manipulation language, now that we will learn the data insertions with SQL. If we want to add a new tuples to course, we can have these statements. Insert into is the keywords and followed by this keyword. We can indicate the relations we want to insert data. And we also have to indicate the values followed by the real data we want to insert into this relation. We also can insert the data with these statements. Insert into course, followed by the attributes we want to insert, and the values indicate these values corresponding to these attributes. And if we want to add the new tuples to students with total credit sets to null, we can write these statements with the statements is similar to the previous examples, but we have to indicate the attributes as null. As to updates, if we want to give 5% salary rise to all instructors, the statement is update instructor set salaries equal to salaries products 1.05. And of course, if we want to update just limited to a group who earns less than $70,000. Here, we can add an whereas clause in which indicates salaries is less than $70,000. And another example is give a 5% salary raise to instructor whose salary is less than average. This update clause combines with subquery. In other words, in the conditions, the salaries compares with the results of the subquery, which is calculate average salaries. And if we want to increase salaries of instructors whose salary is over $100,000 by 3% and all others by 5%, we can write two update statements. One is update instructors set salaries equal to salary products 1.03, where salaries is more than $100,000. And another update statement is similar to the previous. However, set these groups will set salaries equal to salaries products 1.05, where salaries is equal less than $100,000. In these situations, it also can be done by case statement. And the final part of SQL query is aggregate function. These functions operate on the multi-set of values of a columns of a relation and return the values. And there are 5 aggregate functions, including averages, means average values. MIN means minimum value. MAX maximum values. SUM summations of values. Count, which is the functions to calculate the number of values. Here, it provides some aggregate function examples. First, it finds the average salary of instructors in the computer science department. In the previous slides, we have introduced how to find the instructors of computer science. We can specify department names equal to computer science in the where clause. And then we can directly use aggregate function AVG and put salaries in the parentheses of functions as parameters. We can easily to obtain the results of salary average. And the second example is find the total number of instructors who teach a course in the spring 2018 September. You want to query the total number of instructors. So, in addition to the condition, we can directly use aggregate function count, and the ID is the parameters to help us to obtain the number of instructors. And here's things is used to prevent recounts the duplicate instructor. And the next example is find the number of tuples in the course relation. Since we have to count all the tuples, we can ignore the where clause here and directly use aggregate function count. And the star is the parameters of these functions to help us count the number of tuples. And sometimes we have to present the aggregate result from the perspective of group. And here we can use group by clause to satisfy this purpose. For example, find the average salary of instructor in each department. In these tables, instructor ID, name, department names, and the salaries. We can arrange instructor data according to department. In other words, we can group by this instruct data according to the department name. According to the group results, we can calculate the average salaries of this group. For example, only one instructor in department biology, so the average salary is $72,000. As to computer science, there are 3 instructors belongs to this department. We can calculate the average salaries from these 3 salary data. And with SQL, how can we present the purpose of groupings of here we can specify the attribute names followed by keywords group by, which indicates the whole data will be grouped by the department name. And we have to notice that in select clause, we have first indicates the group by its attributes, department names, and then followed by aggregate functions, average, which use salaries as parameters, and if alias needed, we can use as keywords to rename this result. We also can use having clause to fill out the results of aggregate functions combined with group by. For example, for the names and average salaries of all departments whose average salary is greater than $42,000. We have learned about how to combine group by clause with aggregate function. And here we can further fill out the result with some conditions, and the conditions can specify followed by having keywords. It indicates we want to fill out these average salaries are more than $42,000. And it's noticeable that predicates in the having clause are applied after the formation of groups, whereas predicates in the where clause are applied before forming groups. In other words, if the conditions we specify includes the color name, we have to specify the conditions in the where clause. Whereas if conditions containing aggregate functions, we have to specify the predicates in the having clause. And it's the whole contents of this chapter. In these chapters, we explore basic structures of SQL, and we learn about the data definition language and the data manipulation language. These parts, although we go through very quickly, I think we have more times to learn and practice with database systems in physical classroom. And at that times, I think students can learn more from systems practice.